Hello everyone, and thanks for watching Edupedia World Videos. This is the video for the solutions of the mathematics question of paper 2 of JEE Advanced. I will be solving the questions as they appear in code 1. So let's look at the first question. The first question says that for any integer k, let alpha k equal cos of pi k by 7 plus iota sine of pi k by 7, right, which can also be written as e to the power iota pi k by 7. And we need to find the value of a particular expression, which is summation k equals 1 to 12 mod of alpha k plus 1 minus alpha k by summation 1 to 3 k mod of alpha 4k plus 1 minus alpha 4k plus 2. Now all these terms, there are 12 terms in the numerator and there are 3 terms in the denominator. All of them are of the same format, that is alpha, sorry, these are minus. Yeah, these are minuses, I apologize, in the question. Okay, minus 2, yeah. So all of them are of the type alpha t plus 1 minus alpha t, right? Something minus the term after that, k and k plus 1, 4k minus 2 and 4k minus 1. So let's focus on this particular term itself. It is e to the power iota pi k, sorry, in this case t plus 1 by 7 minus e to the power iota pi t by 7, which gives me e to the power iota pi t by 7 times e to the power iota pi by 7 minus 1, right? Now in these cases we have the magnitudes of this. The magnitude of a complex number is the complex number multiplied by its complex conjugate, and in that case the complex conjugate of this would be e to the power minus iota pi t by 7, and when we multiply them they cancel off, right? Another way to say that would be e to the power iota theta doesn't really contribute to the magnitude, right? It just changes the phase of a complex number. So for all of these terms, the magnitude of alpha t plus 1 minus alpha t will be equal to the magnitude of e to the power iota pi by 7 minus 1, whatever that may be, right? We don't need to calculate that, but this is a constant. This does not depend on t, right? So every term has the same value. So the numerator is the sum of 12 terms having the same value. Let's call it a. So the numerator will be 12a and the denominator similarly will be 3a. So the answer will be 4. Right. In the next question, we are given that the terms of an arithmetic progression are all natural numbers, and the ratio of the sum of the first 7 terms to the sum of the first 11 terms is 6:11, right? So the sum of the first 7 terms would be 7 by 2 times 2a plus n minus 1 times d, or 6d, right, divided by the sum of the first 11 terms, which would be 11 by 2 2a plus 10d. This is given to us to be 6 by 11, right? 11 goes, 2 goes, so we are left with a plus 3d by a plus 5d equals 6 by 7. You can cross multiply and it gives you 7a plus 21d equals 6a plus 30d, which implies a is equal to 9d, right? So this is the first relation. Secondly, we are given not only is every term a natural number, but the 7th term is between 130 and 140. The 7th term would be a plus 6d, which, because a is 9d, becomes 15d, right? So we are given that 15d lies between 130 and 140, and d is a natural number, right? So the only option in this case is d is equal to 9, as 15 times 9 is 135. So that is my final answer. d is equal to 9. Right? In the next question, we are given an expression 1 plus x, 1 plus x square, 1 plus x cube, dot dot dot. There will probably be in 1 plus x to the power 9 here, dot dot dot, till 1 plus x to the power 100. So a total of 100 terms. And we are asked to find the coefficient of x to the power 9. Right? Now one term will be 1, which we'll get by multiplying all the ones together. One sum will be x to the power the biggest number, which we'll get by multiplying x to the power 100 to x to the power 99 to x to the power 98 and so on. All other coefficients will occur when we take the sum of the powers of x to be that, and every other term is 1, right, in cross multiplication. So if we take just one bracket to get x to the power 9, then the coefficient will be 1. In this case, we would have x to the power 9, and every other of the 99 terms would contribute the 1 instead of the x. Right? If we try to take two brackets, that means we take two brackets and the sum of the two brackets having the powers of x would be 9. So that would be possible if we take 1 and 8. That is, we multiply 1 plus x to one of the terms here, 1 plus x to the power 8. And if we take this x to the power 8 and this x, and every other term we take the 1, in that case we would get another x to the power 9. We could also get it by 2, 7, or by 3, 6, or by 4, 5. Right? You see what this means? If we have 1 plus x to the power 4 here, then, and 1 plus x to the power 5 obviously, we could multiply those two terms, and x to the power 4 into x to the power 5 would give me another x to the power 9. If every other term we take the 1 value of it, right? We can either take the 1 or the x to the power natural number. So in 4 and 5 we take x to the power natural number, and all other terms we take 1. So these are the 4 combinations. If we take 3 brackets, we can have 1, 2 and 6, or 1, 3 and 5, or 2, 3 and 4. Right? Let's try 4 brackets. 4 brackets means we take 4 brackets and we take the power of x in them, which add up to give me 9. If I take the first 4 brackets, that will be x to the power 1, x to the power 2, x to the power 3 and x to the power 4. So it will be x to the power 1 plus 2 plus 3 plus 4, which is x to the power 10. So if we are taking the product of 4 brackets and 1 in every other of the 96 terms, then at a minimum we will get x to the power 10. So we'll never get an x to the power 9 term by taking 4 brackets. So these are the only alternatives. We get 1 coefficient from here, we get 4 from here, and we get 3 from here. So the final answer will be 8. We get 1 x to the power 9 from this term. We get 4 more x to the power 9 from the product of 2 terms, such as x to the power 8 and x to the power 1. And we get 3 more x to the power 9 from the product of 3 terms, such as x to the power 1, x to the power 3, and maybe x to the power 5. If we multiply these 3 and every other term we take the 1 part, we'll get x to the power 9. Let's look at the next question. We are given that the foci of the ellipse x square by 9 plus y square by 5 is equal to 1 are f1, 0 and f2, 0. The ellipse is x square by 9, that is x square by 3 square, plus y square by 5, that is y square by root 5 whole square, is equal to 1. Right. So this is the ellipse. We can easily find the focus. We have to first find the eccentricity. The eccentricity will be root of 1 minus b squared by a squared, right? That is root 5 whole squared by 3 whole squared. So 1 minus 5 by 9, that is root of 4 by 9, that is 2 by 3. And the foci are at plus minus AE, that is in this case 3 multiplied by 2 by 3, that is plus minus 2. So we know that F1 is 2 and F2 is minus 2. Right, because we are given that F1 is positive and F2 is negative. Then we have two parabolas with the common vertex 0, 0 and foci at F1, 0 and F2, 0. That means the foci are at 2, 0 and minus 4 comma 0. These are two different parabolas, right? P1 and P2. So let's write the equations. P1, y square is equal to 4ax, that is y square is equal to 8x because a is 4 in this, a is 2 in this case, and for P2 it will be y square equals minus 16x, again 4ax where a is minus 4, right? So now tangent to a parabola, you need to remember these equations. The tangent to a parabola can be given by the characteristic parametric form y is equal to mx plus c, where c has to be equal to a by m, right? So y is equal to mx plus a by m for different values of m gives you a tangent to the parabola y square is equal to 4ax, right? So in this case we are given t1 is a tangent to p1, right? So P1 has a is equal to 2. So that means T1 will be y is equal to mx plus 2 by m. We are given T1 passes through 2f2 comma 0. 2f2 is minus 4. So this passes through minus 4 comma 0. That means y is 0, x is minus 4. Let's take this to be m1 for T1 and m2 for T2. Right. So this equation satisfies minus 4 comma 0. That means minus 4 m1 is equal to 2 by m, minus 4 m1 plus 2 by m1 equal to 0, which gives me m1 square is equal to, this will give me equal to 4m1, so m1 square will be equal to 1 by 2, right? Similarly, we can do this for the second one, and the second one we'll get y is equal to m2x plus a by m2, but a in this case is minus 4, so minus 4 by m2, and we are given this passes through m1 f1 comma 0. f1 is 2, so this passes through 2 comma 0, so 2m2 minus 4 by m2 equals 0, which gives me m2 square is equal to 2 and m1 square is equal to 1 by 2. We need 1 by m1 square plus m2 square, that is 2 plus 2, so the final answer is 4. Right. Let's look at the next question. We are given that m and n are two positive integers greater than 1 and limit a goes to 0 e to the power cos of a to the power n minus e by e to the power m is equal to minus e by 2, and we need to find the value of m by n, right? So first we can do this, we can take, sorry, this is a, yeah. So first we can take 1e out. I'm not going to write limit anywhere this term, but it's understood, right? So first we can take e out, and it will be e times e to the power cos a to the power n minus 1 by a to the power m. Now I'll cross multiply by another term, which you can easily see y into cos of a to the power n minus 1 by a to the power m, right? Because we know if x goes to 0, then e to the power x minus 1 by x has a limit equal to 1, right? So x in this case is cos a to the power n minus 1. When a goes to 0, cos a goes to 1, so cos a minus 1 goes to 0, right? So this term, basically these two have the same limit, so we can cancel them out. So we get e times, now cos a to the power n minus 1, I can write it as minus 2 sine squared a to the power n by 2, right? Because that's the formula for cos 2 theta. It's 1 minus 2 sine square theta, right? Divided by a to the power, divided by a to the power m, right? So this gives me minus e, this 2, now this I can write it as a to the power 2n by 4, right? Because sine of theta is equal to theta when theta goes to 0. So minus e into a to the power 2n multiplied, divided by 2 a to the power m. This is given to us to be minus e by 2. That means a to the power 2n minus m is equal to 1. That means 2n minus m equal to 0. That means 2n equals m. That means m by n equals 2. So that is my final answer. Right, m by n equals 2. Let's look at the next question. So we are given an integral which is alpha is the integral from 0 to 1 e to the power 9x plus 3 tan inverse x. Now I'm sure after I've written this much down, you know the question which I'm talking about, so I'm going to just simplify in the very first step. The next term to me given is 12 plus 9x square divided by 1 plus x square, right? And now I can split it and write it as 9 plus 3 by 1 plus x square. This is the only thing that is actually being tested in the question, that you need to look at 9x plus 3 tan inverse x, and you need to realize that the second term can be actually simplified as a derivative of the first term, right? So now it's easy enough. We can take 9x plus 3 tan inverse x to be t, then this whole thing will be dt, and my final answer will be e to the power 9x plus 3 tan inverse x from 0 to 1, right? So for 1 it will be e to the power 9 plus 3 pi by 4 minus for 0 it will be 1, right? So this is alpha. So alpha plus 1 will be e to the power 9 plus 3 pi by 4. So we need to find out ln of 1 plus alpha minus 3 pi by 4. So we can easily see that that is equal to 9. We take 1 plus alpha, that will be 9 plus 3 pi, the log of that will be 9 plus 3 pi by 4. You subtract 3 pi by 4 and you'll get 9. Right. In the next question, I am given a continuous odd function which vanishes exactly at one point, and f of 1 is half, right? And we are given that limit x goes to 1, capital F of x by capital G of x is equal to 1 by 14. So let's start simplifying that. That can be written as limit x goes to 1, integral of 1 to x f of t dt by integral of 1 to x t mod f of t dt, right? This is what has been given to us. Now the important thing to see here is that I've changed the limits in this case. Gx is actually, this should be x. Gx and fx are actually both from minus 1 to x, but I've taken them to be from 1 to x instead of from minus 1 to x. And the reason for that is that f is an odd function, right? So because f is an odd function, integral of minus 1 to 1 f of x dx will be 0, right? Because f of half will be equal to f of minus half, right? And they'll all cancel out. So it was originally minus 1 to x. I could write it as minus 1 to 1 minus x to 1, right? And in that case minus 1 to 1 will become 0, right? So, and in the second case we can do the same thing, because this mod is always positive, so it converts an odd function to an even function. You multiply it by t, it again becomes an odd function, right? So after this we can use L'Hopital's rule and just differentiate both of them. So all we'll get is whatever is inside the integral. So that means we'll get that 1 by 14 is equal to limit x goes to 1 f of x by x times f of x, right? And we know certain things for x is equal to 1. We know f of 1 is half, right? So we get 1 by 14 is equal to half divided by x is 1 into f of half, right? Because again f of x is half. So f of half comes out to be 7. So this is my final answer. Now the next question, there's a particular thing in the next question. We are given that P, Q and R are three non-coplanar vectors and the components of S along P, Q and R are 3, 4 and 5. And we are given a bunch of other information. Now I wasn't able to solve this question and I looked around on the internet, and other places are also saying that there's a problem in this question, which is that there's not enough data given. Right, so it probably will be a bonus question as far as I can tell, because the answer would be different depending on the magnitudes of P, Q and R. We are given that there's a vector X, there's a vector S, then the component of S along a vector P is a certain value. Now that value is actually independent of the magnitude of P. The magnitude of P could be 10 or 5 or 2 or 0.5. The component of X in that particular direction will always remain the same, which in this case is given to be 4. Right? But later we are asked some particular values which actually do depend on the magnitude of P. So either the magnitude of P, Q and R should be given, or it should be given that they are unit vectors, or some other relation should be given. Currently it seems to me that there is not enough data given in this question, and this question has some errors in it. Right, let's move on to the next one. Now we are moving on to the next section of objective questions. So the first question is, let S be the set of all non-zero real numbers alpha such that the quadratic equation alpha x squared minus x plus alpha equals 0 has two distinct real roots, satisfying the inequality mod x1 minus x2 less than 1. And we want to basically find out the interval. Right, so the first thing to do is, we know that we are given two distinct real roots. That means d has to be greater than 0. Right, so b square, that is 1, minus 4 alpha squared has to be greater than 0, which means alpha squared has to be less than 1 by 4. Which means alpha is between minus 1 by 2 and 1 by 2. But that's not all. This is for this to have two distinct real roots, but we also need to put the other condition, mod of x1 minus x2 is less than 1. Right, so that means x1 minus x2 whole squared is less than 1. That means we can write it as x1 plus x2 whole squared minus 4x1 x2. We are given this is less than 1. Right, we know x1 plus x2 is 1 by alpha and x1 x2 is 1. So this means 1 by alpha squared minus 4 less than 1, which means 1 by alpha squared less than 5, which means alpha squared greater than 1 by 5. So if we take this and the intersection of this, the actual result we get is minus 1 by 2 to minus 1 by root 5 and 1 by root 5 to 1 by 2. Right, because if alpha squared has to be greater than 1 by root 5, but it has to be less than 1 by 2. That means alpha has to be greater than 1 by root 5, but alpha has to be less than 1 by 2. Right, so these are the two. We can see option A does indeed lie in this interval. Option A is minus 1 by 2 to minus 1 by root 6. And since root 6 is greater than root 5, that actual interval lies within this interval. Right, the second and third interval do not lie, and the fourth interval is 1 by root 5 to 1 by 2, which also lies within this. So the answer would be A and D. In the next question, we are given two angles. Alpha is 3 sine inverse 6 by 11 and beta is 3 cos inverse 4 by 9. And we are asked to find out cos alpha, the sines of cos alpha, cos beta and so on. Now, 6 by 11 is slightly greater than, you can actually put in the direct values and use formulas for cos 3 theta and so on, but there's an easier way to do this. 6 by 11 is actually slightly greater than half, right? That means sine inverse 6 by 11 will be slightly greater than pi by 6. So that means alpha is slightly greater than pi by 2, right? Similarly, 4 by 9 is slightly less than half. So cos inverse 4 by 9 is slightly greater than pi by 3, right? So that means beta is slightly greater than pi. So now cos beta will be negative. There's no chance of going it into the fourth quadrant because we are talking about beta is slightly greater than pi, right? So if beta is slightly greater than pi, cos beta has to be negative. So the first option is wrong. Sin beta also has to be negative. So the second option is correct. Now alpha plus beta is slightly greater than 3 pi by 2. So alpha plus beta lies in the fourth quadrant, right? Somewhere here. So cos of alpha plus beta is indeed positive. So the third option is true. And cos of alpha is negative because it's in the second quadrant. So the answer to this will be B, C, D. Right. Let's look at the next question. We are given E1 and E2 are two ellipses whose centers are at the origin, right? And we are given that there is a circle x squared plus y minus 1 whole squared equal to 2, right? And the straight line x plus y is equal to 3 touches this curve at S, right? So let me try to draw a figure. The center of the circle is at 0, 1 and the radius is root 2. So the circle will probably be something like this. And we are given x plus y is equal to 3. That line will probably be something like this. This point is given to be P, right? And there are two other points at which this circle is touched at Q and R, which is touches the two ellipses, right? So let's take this point to be Q and this point to be R. We are given that PQ is equal to PR is equal to 2 root 2 by 3. And because they are distinct ellipses, it makes sense that they have to be on the opposite sides of this line, right? So this is a tangent to this circle, which is also a tangent to two ellipses, and we want to find the relation between the eccentricities of the ellipses, right? So first let's try to solve where these two equations meet, right? So we can put y as 3 minus x, so we'll get x squared plus 2 minus x whole squared is equal to 2, which gives me 2x squared minus 4x plus 2 equals 0, which gives me x squared minus 2x plus 1 equals 0, which gives me x is equal to 1, which gives me y is equal to 2. So point P is 1, 2. Right. Now what we need to do is we need to find Q and R. Right. If we can find point Q, then we can find the eccentricities of the ellipses, because we know that both the ellipses are of the form x squared by a squared plus y squared by b squared equal to 1. Right. This is the form for both the ellipses because it's given that the major and minor axes are along the x and y direction. Right. So we just need to find these 2 points, and that's easy enough. We can do it many different ways. One of the easiest way, according to me, is using the parametric representation. So we can take this point to be x, and y will be 3 minus x, because it lies on the line x plus y is equal to 3, and we can calculate the distance between these 2 points, and that has to be equal to 2 root 2 by 3, right? That means root of 1 minus x whole square plus 2 minus of 3 minus x, that is 1 plus x whole squared. 1 plus x whole, actually wait a second, this is 2 minus of, right, so that becomes minus 1 plus x, so it's actually 1 minus x, the same as that. My bad, right? This is given to us to be 2 root 2 by 3, right? That means mod of 1 minus x, because this will be 1 minus x times root 2, right? This is given to us to be 2 by 3, That means 1 minus x is equal to plus minus 2 by 3, which means x is equal to, let it here, x is equal to, if it's 2 by 3, then x is equal to 1 by 3, and if it's minus 2 by 3, then x is equal to 5 by 3. So y in these cases is 3 minus x, so it will be 8 by 3 and 4 by 3. So this is, one of these is q and one of these is r. It doesn't matter which is which, right? So these are my two parabolas. We can find the two eccentricities now. Eccentricities, e square is equal to root of 1 minus b squared by a squared, right? And these satisfy these equations. So if we take, actually you don't get it from this equation, you could get it from this equation. If we differentiate this, we get 2x by a square plus 2y by b squared y dash is equal to 0, right? And the tangent at this point is x plus y is equal to 3, so y is equal to 3 minus x, so the derivative y dash is minus 1, right? So from that I can see that b squared by a squared is equal to y by x at this point, right? So for this it will be 8, so b squared by a squared can be 8 or it can be 4 by 5, right? So using these two I can find the eccentricities, hang on, right? But if b square is greater than a square, then this formula becomes root of 1 minus a squared by b squared, right? So in the first case we'll have to use this formula, in the second case this formula. So we'll get e1 squared is equal to root of 1 minus a squared by b squared, which is 1 by 8, so e1 squared comes out to be 7 by 8. Similarly, e2 square will come out to be root of 1 minus 4 by 5, so it will come out to be 1 by 5. So these are my two final answers. I apologize that this has gotten a little messy, so I'll try to repeat it once more, right? We knew that x plus y is equal to 3 is a tangent to the circle x square plus y minus 1 whole square is equal to 2, right? So we substituted this, we calculated x is equal to 1, y is equal to 2. This was this point P, right? The line is x plus y is equal to 3. We needed the 2 points which were at a distance plus minus 2 root 2 by 3 from this point P, Q and R. So we took a parametric point to be x comma 3 minus x, and we took the distance to be 2 root 2 by 3. That gave us 2 values of x, which gave us 2 values of y. So these are our 4 points, right? This point lies on the first ellipse E1, this point lies on the second ellipse E2. Then our job was to find the eccentricities of the ellipse, which we found out using this formula, which we got as 7 by 8 and 1 by 5, right? E1 square is 7 by 8 and E2 square is 1 by 5. So using these you can see that the first option and the second option are correct, whereas the third and fourth option are not correct. So the answer in this case is A and B, right? Let's look at the next question. We are given a hyperbola. Now this question will be easiest to try to do in terms of a figure. So this is our hyperbola, x squared minus y squared is equal to 1, right? And we have a circle at x2 comma 0, right? There's this point which is x1 comma y1, which is point P. From this point P, we are given x1 is greater than 0 and x1 is greater than 1 and y1 is greater than 0. And the common tangent to these, that means this could probably be the circle. I apologize for my drawing. It actually should be symmetric up and down, but that doesn't matter for us. And let's say this is the common tangent, right? So let's call this as x3 comma 0, right? And this angle is 90 degrees. So we have 3 points, x2 comma 0, x3 comma 0 and x1 comma y1. We can take a parametric point on this particular hyperbola as sec theta comma tan theta. Right. Now L and M, L comma N is given to us to be the centroid of this triangle. We know the centroid is x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. Right. So this means L is x1 plus x2 plus x3 by 3, whereas M is simply y1 by 3 because these two have a y coordinate equal to 0. Right. Now, first of all, this is a tangent to this equation. So the generic equation for the tangent will be, I'm sure you know this, x sec theta minus y tan theta is equal to 1. Right. And so from this we can get, by putting y is equal to 0, that x3 is equal to 1 by sec theta. That can also be written as 1 by x1. So this is the first relation we've gotten, that x3 is 1 by x1. The second equation, to get the relation between x2 and x1, we can use the fact that these two lines are perpendicular to each other. So the product of their slope is minus 1. So we'll get y1 by x1 minus x2 into y1 by x1 minus x3 is equal to minus 1. Right. And we can put the values of y1, x1 and x3. So we'll get tan squared theta divided by x1 minus x2 will be sec theta minus x2 times x1 minus x3 will be sec theta minus 1 by sec theta. So that can be written as sec square theta minus 1 multiplied by sec theta. Sec square theta minus 1 and tan theta cancel. We are given that this is minus 1. So if we try to solve it further, that gives us sec theta is equal to x2 minus sec theta, right? Which basically gives me x2 is 2 sec theta. So we get x3 is 1 by x1 and x2 is equal to 2x1, right? So now the problem is solved. We can get L as x1 plus x2 plus x3 by 3. That will be basically 3x1 plus 1 by x1 by 3. So it can be written as x1 plus 1 by 3x1, and M will simply be y1 by 3. y1 can be written as root of x square minus 1 if needed. So it can also be written as root of x square minus 1 by 3. Right. So now we can try to solve. The first option asks us what is dl by dx1. dl by dx1 is 1 minus 3 by x1 squared. Right. So this gives me the first option to be correct. The second option, what is dm by dx1? So if we write it as root of y squared can be written as x squared minus 1. So the derivative of that would be, this is to the power half, so 2 will come down. So we'll get root of x square minus 1. So we'll get, and upper we'll have a 2x and 2 will cancel. So we'll get x1 by 3 times root of x1 square minus 1. Right. So the second option is correct as well. The third option is incorrect because it's different from the first option. The fourth option we can directly see dm by dy1 is equal to 1 by 3. So the answer to this question will be A, B and D. Right. Let's look at the question after this. We are given an integral from 0 to 4 pi, a particular function which I am just going to write as f of t. Right, the question is integral 0 to 4 pi e to the power t times sine to the power 6at plus cos to the power 4at dt. Right, so that particular function e to the power t times sine to the power 6at plus cos to the power 4at, I am writing it for the moment as f to the power t. Right, so we are getting integral 0 to 4 pi f to the power dt by integral of 0 to pi f to the power dt. Right, now the only options are available to us are a is equal to 2 or a is equal to 4. That is, a is even. Right, for an even a, we can see that f of t plus k pi is equal to e to the power k pi times f of t, because this will become multiplied by k pi, so e to the power k pi will come. Now if we take this plus k pi and a is, let's say, 2, right? So 2t goes to 2t plus k pi, that is 2t plus 2k pi. And we know that if it's an integral multiple of 2 pi, it doesn't make any difference because all trigonometric functions are cyclic with period 2 pi, right? So basically this will give us the exact, and when we add by pi the limits go back, right? So it will become 0 to pi, then pi to 2 pi. If we take t dash is equal to t plus k pi, it will again become 0 to pi, and so on. So ultimately this will give me 1 plus e to the power pi plus e to the power 2 pi plus e to the power 3 pi, right? Because first I'll break it as into 0 to the pi, and 0 to pi will be the same as this, it will give me 1. Then pi to 2 pi will be the same as e to the power pi times 0 to pi, because the limits will change, right? If we have 2 pi to 3 pi and we take t dash is equal to t plus 2 pi, so 2 pi to 3 pi will again become 0 to pi, and we get a factor of e to 2 pi, right? So adding these up, this is basically a geometric progression. This can be seen as e to the power 4 pi minus 1 by e to the power pi minus 1. This is L, and this is the same for all even a. So it is true for a is equal to 2, and it is true for a is equal to 4. So my final answer in this case is A and C, right? Let's look at the next question. The next question is my favorite question out of this paper. So it's a very easy question because it doesn't take a lot of time, but it's slightly tricky, right? And I like these types of questions. The question given to us is simply we are given 3 values of fx and gx at x is equal to minus 1, 0 and 2, and the values are 3, 6, 0 and 0, 1, minus 1. And we are asked to calculate the properties of the function fx minus 3g of x. The first thing we can, let's call this h of x. The first thing we can see that it's 0 at minus 1, 0 and 2, right? 3 minus 3 times, sorry, it is 3 at all these 3 values. 3 minus 0 is 3, 6 minus 3 times 1 is 3, and 0 minus 3 times minus 1 is also 3, right? So hx is equal to 3 at these values. Let's draw the figure. This is x is equal to minus 1, this is x is equal to 2. So these 3 points are points through which the function passes, right? And we are given that the double derivative of this h double dash x is never equal to 0, is never equal to 0 between minus 1 to 0 and 0 to 2, right? Now one option could be it's an actually straight constant function, right? Can there be any other option? There can be some other options. We can't draw a function. Okay, let me just talk about this for a second first. A function like this, which changes its inflection. Right now it's concave downwards, right? And here it's concave upwards. So if it's changing its concavity, then there has to be a point of inflection in the middle. A point of inflection will be a point where the double derivative will be 0. We know that. If the double derivative is not 0, that means the concavity cannot be changing. So there are only a few options for this. It can either go like this or it can go like this, right? Of course other variations of this, but it can either be concave downwards between minus 1 to 0, or it can be concave upwards. If the inflection, if it cannot be something like this, because the inflection cannot change from concave downwards to concave upwards without the double derivative being 0 in between, right? So that's the only tricky part in this question. So it's one of these two, right? Let's assume it's like this. Again, the second case it could be like this or like this, but if the first case it's like this, second case it has to be like this, because we are given that it's differentiable at 0, right? So either something like this or something like this or something like this. These are the only possibilities. There is no other possibility, right? So let's look at the first one. Now f dash x is 0 once between minus 1 and 0, and it is 0 once between 0 and 2. So h dash x has two solutions, one between minus 1 and 0 and the other between 0 and 2, right? So from this we can see that options B and C are correct. Right, this is the most important part in the question, that h dash x is not equal to 0. If h dash x was allowed to be equal to 0, then we could have had a million different ways in which these 3 points could have been satisfied. But if a function has to pass through these 3 points and it has to not change its concavity between 0 and between -1 and 0, then it's either concave upwards or concave downwards. Right. Let's look at the next question. In the next question, we are given a function. Now I'm just going to write t for tan x, just to make it short, because we don't have any other trigonometric arguments here, right? So we have 7t to the power 8 plus 7t to the power 6 minus 3t to the power 4 minus 3t squared, right? From minus pi to pi, right? So if we try to solve this, we can simplify this and we can take t squared common, and it will be, sorry, we can take 7t to the power 6 common, and it will be t squared plus 1 minus 3t squared, and it will be t squared plus 1. So if we factorize this thing, it will be 7t to the power 4 minus 3 times t squared plus 1. I'll just write as s squared, right? T is tan theta, s is sec theta. We know that 1 plus tan square theta is sec square theta, right? So this is f of x, right? Now first of all we need to find integral 0 to pi by 4 f of x, right? So that we can do easy enough. We can put tan theta as t, and we'll get sec square theta d theta as dt. So the final integral will become integral. Now 0 to pi by 4, if we put tan theta is equal to t, it will become 0 to 1, right? Because tan pi by 4 is 1. So now we'll take that to be, let's say, y. So we'll get 7y to the power 6 minus 3y square dy, right? This is the final answer. So if you try to calculate that, it will be y to the power 7 minus y cube from 0 to 1, right? Which will be 0 minus 0, which will be 0. So we found out that this is equal to 0, right? That gives me a few options right away. Integral of f of x from 0 to pi by 4 is 0. So that makes option B correct straight away, right? Next we need to think about integral 0 to pi by 4 x f of x, right? So we can use integration by parts to do it. That will be first terms times the integral of second term. So it will be x times integral fx dx, which we know as y to the power 7 minus y cube, right? Where y is tan of x, right? This is x and this is tan of x, minus integral of the derivative of the first function multiplied by the integral of the second function, y to the power 7 minus y cube, right? So this from 0 to pi by 4, x going from 0 to pi by 4 is 0, right? We know that. This term, if we simplify it further, this term comes out to be minus integral of 0 to pi by 4, right? Y to the power 7 minus y cube we had. So tan to the power 7x minus tan cube x dx. This is what is left, right? So now we need to simplify this. This can be written as minus integral 0 to pi by 4 tan to the power 4 tan cube x times tan to the power 4x minus 1. So that will be tan square x minus 1 into tan square x plus 1, which is just what I was looking for, which is sec square x dx. Now again we can do the exact same thing. We can put tan x is equal to t, and what we are getting actually is integral of minus integral of 0 to 1 t to the power 5 minus t cube. That is, so the limits t to the power 6 by 6 minus t to the power 4 by 4, right? Now it's not an integral, it's 0 to 1. I've directly integrated it. This is t to the power 5, which will give me an integral of t to the power 6 by 6. This is minus t cube, which will give me an integral of minus t to the power 4 by 4. So the final answer comes out to be 1 by 4 minus 1 by 6, which is 1 by 12. So integral of 0 to pi by 4 x f x dx comes out to be 1 by 12, which gives me option A. So the answer to this question is A and B. Right. In the next question, we are given f dash of x, f dash of x is equal to 192 x cube by 2 plus sine to the power 4 pi x, right? And we are also given that f of half is 0. So let's look at a few important things in this question. F dash of half will come out to be 8, right? It will be 192 divided by 8, and that will be 24, and divided by 3, so it will be 8. F dash of 1 will be 96. It will be 192 divided by 2, because sine of pi is 0, right? Now let's draw the figure for this. This is x is equal to half, and this is x is equal to 1. This is a point through which the function passes, because f of half is 0, right? Now one thing to note is that f dash of x, as x increases, the numerator increases, right? We are going from half to 1. As x goes from half to 1, the numerator keeps on increasing. And x goes from half to 1, this term goes from pi by 2 to pi, right? So this term keeps on decreasing from pi by 2 to pi, right? So the numerator increases and the denominator decreases. So this whole fraction keeps on increasing. So f dash of half is 8 and f dash of 1 is 96. F dash of anything between half and 1 has to be greater than 8, because this is a monotonically increasing function, right? So let's take the two limits. The lowest limit of the function would be if f dash of everything would be 8. In that case, the slope would be 8. I apologize, the figure is not really drawn to scale. The y-axis seems to be shorter than the x-axis. This side will be 4, because 4 divided by half will be 8, right? So this would be the function if the slope were 8 everywhere between half and 1. This would be the function if the slope were 96 everywhere between half and 1, right? This total thing would be 48, and 48 divided by half would be 96. So the actual function has to lie between these two. It probably has to be something like this, right? It could maybe be something like this, but to me it looks like it will be something like this, because initially the slope is 4 at the 8, and finally the slope is 96. Anyway, it doesn't matter how it behaves, as long as we know that it has to lie between these two triangles, right? What are the equations for these two lines? This line would actually have the equation y is equal to 8x, except it is not starting from the origin. This is x, so this distance will be x minus half, right? For any point, this point is x, so this distance is x minus half. So the equation for this line is y is equal to 8 times x minus half. And the equation for this bigger line, similarly, is y is equal to 96 times x minus half, right? And we know that f of x has to lie between these two values. So integral of half to 1 f of x dx has to be less than equal to integral, actually not even equal to, because we know it's changing between the two, half to 1 96 x minus half dx, which comes out to be 96 times x will be, integral of x will be x squared by 2, 1 squared by 2, that is half, minus half squared by 2, that is 1 by 8, so it gives me 3 by 8, minus half into half is 1 by 4, so that is 2 by 8, which gives me 96 into 1 by 8, which gives me 12. So the upper limit is 12. Similarly, the lower limit would be half to 1 8 x minus half dx. Right, now you can try to do this exactly the way we did this, or I can just see that 96 divided by 12 is 8, so this limit will be 1/12 of this, so this will be 1. So 1 less than this integral less than 12. So my answer is small m is equal to 1 and capital M is equal to 12. That means my answer is D. Let's look at the next question. Now we begin paragraph questions, and the first one is a paragraph based on permutation and combination. We are given two boxes. The first box has n1 red balls and n2 blue balls. The second box has n3 red balls and n4 blue balls. And we take a ball from a random box and it is found to be red. And then we see that the probability that this red ball comes from the second box is 1 by 3. Sorry, 1 by 3. That means obviously the probability that it would have come from the first box would be 2 by 3. Right? Now what is the probability that we get a red ball from the first box? That is n1 by n1 plus n2. n1 plus n2 total balls, n1 red balls. And this would be n3 by n3 plus n4. This is 2 by 3 and this is 1 by 3. So basically this should be twice of this. Right. Actually this need not be 2 by 3 and 1 by 3, they just need to have this ratio. So you can put down the values of n1, n2, n3, n4 from, you cannot solve for the values because we have 4 variables in one equation. But you can put values from the options and you'll find out that option A and B satisfy this result, whereas option C and D do not. So this is my answer, A and B. In the next question, in the next part of this question, we have the same setup, n1 red balls, n2 blue balls, and another box, n3 red, n4 blue. We take one ball from this into this, and after that we calculate the probability of picking up a red ball from this box. So when we take an object, one ball from this box to this box, it could have either been a red ball or a blue ball. The probability of it being a red ball would have been n1 by n1 plus n2. And the probability of it being a blue ball would have been n2 by n1 plus n2. Right. Now let's say we took the red ball, the probability is n1 times n1 plus n2, and after that we want to find the probability of getting the red ball in this. So now we have n1 minus 1 red balls left and n2 blue balls left. So it will be n1 minus 1 by n1 plus n2 minus 1. There will be a plus because this is the second case. The first case, the probability, this is for picking out the red ball and putting it into the other box. This is for picking out a red ball after that. This is the probability of picking out a blue ball from the upper box. After that we have n1 red balls and n2 minus 1 blue balls. So then the probability of getting a red ball would be n1 by n1 plus n2 minus 1. We are given that this net probability is equal to 1 by 3. There's no really need to simplify this. You can just try to put in the values given in the options for this, and you will see that this is valid for C and D. So this is my answer. Right. In the next paragraph question, we are given a function fx such that f of 1 is equal to 0, f of 3 is equal to minus 4, and f dash of x less than 0 for all x between 1 and 3. In the question it's actually given for all x between half and 3, but our region of interest is only 1 and 3, so I might as well just write that. The first thing to note is that f of 1 is 0 and f dash of x is 0 in this interval. We are only interested from 1 to 3, remember that, right? So if f of 1 is 0 and f dash x is negative, that means f of x is decreasing. That means f of x has to be less than 0 for all x between 1 and 3. Right, 1 is not included in this case, 3 we don't care about. Right, because f of 1 is 0, but as we go further out away from 1, f of x decreases. So it has to be less than 0 for all cases. We are interested in the function f of x, which is capital F f of x, and we want to find the derivative of this function. So f dash of x, we can use the product rule. It will be f of x plus x f dash of x. Right. Now for 1, f of 1 is 0. 1 is positive and f dash of 1 is negative. Right, that is given to us in this case. So this is less than 0 for x is equal to 1. Similarly, for x is equal to 2, we know that f of 2 is negative by this relation, and we know f dash 2 is negative by this relation. So it is negative for x is equal to 2 also. In the third and fourth option, we want to find out whether this can possibly be 0 for x between 1 and 3. So f of x is always negative between 1 and 3. F dash x is always negative between 1 and 3. And x is always positive between 1 and 3. That means the product of these two is negative between 1 and 3. And the sum of two negative numbers can never be equal to 0. So fx is not equal to 0 for x between 1 and 3. That means the answer to this question will be options A, B and C. Now let's look at the next part of this question. So we are given two integrals. I1 is integral of x squared f dash of x from 1 to 3, and we are given that this is minus 12. Also we are given I2, which is integral from 1 to 3 x cube f double dash x is equal to 40, right? So first of all, let's write down a few easy results. F of x is f of x by x, right? Which means f dash of x is equal to, by quotient rule, x f dash x minus f of x by x squared. Which means again we can apply quotient rule to find f double dash of x, which will be by x to the power 4 x squared times f dash x minus x f double dash x minus f dash of x minus x f dash of x minus fx times 2x. Right, I've just used a product rule. Now I've simplified this already, and you can later verify that this comes out to be x square f double dash of x minus 2x f dash of x plus 2f of x by x cube. Right, you can simplify this term and it comes out to be equal to this. So now we know x square f dash x, right? That is the numerator in this case, and x cube f double dash x is the numerator in this case, right? So we'll just substitute these two values. Let's look at the first integral first. We are given I1, which is integral of 1 to 3. Now I'm just going to substitute the value of x square f dash x, right? So x square f dash x will be x f dash x minus f of x. This is equal to minus 12. Now here we need to use a little trick. I can see that if this was plus in this case, that would have been the derivative of x f of x, right? X f of x has the derivative x f dash x plus f of x, right? So in this case, what I can do is I can just add that. So 1 to 3 x f dash of x plus f of x dx, that will be equal to minus 12 plus 2 times integral of 1 to 3 f of x dx. I've added this term to both sides, and this side time it will become a plus, right? So now what is this? This is the derivative of x fx, right? So if you integrate it, you'll get the original thing with the limits. So x f of x with the limits 1 to 3 is equal to minus 12 minus 2. Let's call this integral alpha, which is what I need to find out, right? So this can be written as x square capital F of x from 1 to 3. Now we know capital F of 1 is 0. That is already given to us in the question. And we know capital F of 3 is minus 4. So the lower limit becomes 0. The upper limit becomes minus 4 multiplied by the square of this, which is 9. So we get minus 36. That is minus 12 minus 2 alpha, which gives us alpha is equal to minus 12. So this integral is equal to minus 12. Now before going on to the second integral, let's try to calculate integral of x f dash x first. So we get simply from here integral from, I'm not going to write the limits anymore because it's cluttering things up, but all the limits are from 1 to 3, right? So integral of x f dash of x minus minus 12 is equal to minus 12. Right, we are inputting the value of integral fx in this case. So this gives me integral of x f dash of x is minus 24 from 1 to 3. Right, this is the second result. We'll use both these results in I2. So I2 is given to us and I can substitute the value of x cube f double dash x, and it will simply be integral of 1 to 3 x square f double dash of x minus 2x f dash of x plus 2 f of x, and it is given to us to be 40. Now again I'll use the same trick. I know if this was plus, then these two terms together would be x squared f dash x derivative, right? The derivative of this would be x squared f double dash x plus 2x f dash x. So I'll just do that. So I'll get 1 to 3 x squared f double dash x plus 2x f dash x dx. What is this equal to? This is equal to 40 minus 2 times integral of 1 to 3 fx dx plus 4 times this 2 and another 2. So plus 4 times integral of 1 to 3 x f of x dx. Right, and this is equal to this term, which is the derivative of this term. So this will simply be x squared f dash of x with the limits from 1 to 3, not an integral now. So this gives me 9 f dash of 3 minus f dash of 1 is equal to 40 minus 2 times minus 12 plus 4 times minus 24, which is 40, this is 64 minus 96, this is minus 32, which means 9 f dash of 3 minus f dash of 1 plus 32 equal to 0. So previously I got D, now I get C. So the final answers in this case are C and D. This completes the mathematics solutions for paper 2. Thank you.